All right. So exam is 1 week from today. Your exam's 33 multiple choice questions. You can use your formula sheet. You can use your calculator. I will bring calculators. You also will have calculators on your computer. If you have your own calculator, you can use your own calculator. I will check to make sure that they don't have programs. We did start doing the final exam review last time, and I'm kind of picking up right where I left off last time. Remember, I'm still going to leave this out there in the notes that whatever your average is, multiply it by 0.80, plus your final exam, multiply that by 0.20, and that will give you your final average. In this class, we're on the 10-point grading scale, so 90 and higher is an A, in the 80s is a B, and the 70s is the C, and remember, you can make a D in some degrees, so check with your advisor if you do make a D. Now, when we had left, we were talking about stem and leaves, and I think we went over all of that, but I just wanted to double check. Your test will be multiple choice. So, sometimes they'll have the line, sometimes they won't. You won't be able to write on the screen like I have, so you can either go over to the side, or what I usually do is I find a set, like I would not look at the hundreds because they all have 100. So I would go to something that has something different. So maybe start with the 67s. So if it has a 67, then we know we can mark out this one. And then go to something that's different. So if you don't want to write them all out, just see what's different. So that was a stem and leaf. This is another stem and leaf. This one just shows it to you with the line where the other one didn't show the line. Are we good with stem and leaf? Now, this one showed the scatter plot. And it had where you click the icon, so I came down here, and I think we talked about this one, where your L1 was here and continued over here, and your L2 was here and continued over here. And then once you did Zoom 9, so we did Stat Edit, and then we did Zoom 9. So we did Stat Edit, where this was your L1, this was your L2, this was your L1, this was your L2, okay? And then after we did Stat Edit, we did Zoom 9. All we wanted to do was look at it. And then we found which one looked alike. And remember, I think we actually did this problem, and I said it wasn't a whoop-whoop, it was a run. Okay, so it was this one over here. And then if they ask you, I think this one asked you, did it have a correlation or not? And this one was all over the place, so it didn't have a correlation. Now, I'm going to show you some in just a minute, but if it goes uphill, you would say, yes, it has a correlation. And you would say, if it goes uphill, it would be as one increases, the other increases. So if you're going uphill, they're both increasing. They're both going uphill. If it goes downhill, it's going to say, as one increases, the other decreases. So as it's going downhill, they're going to go in opposite directions. As it goes uphill, they're going to go in the same direction. Okay? So there's one of those. Here's another one very similar. This time for your data, your L1 is in 3 columns. Your L2 is in 3 columns. So you would go and you would list the tar, L1, 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 all in one column. And then L2, 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 all in the second column. So you would do your Stat Edit, Stat Edit, and then we would just do Zoom 9, look at me. And there would only be one set of data that's going to match. Now these look really close, but there's only going to be one that's going to match, and that's going to be this one. Okay? Now, the last thing that it says is there a relationship? Now there's 2 that says yes, there's a relationship. Now because it's going uphill, it's going to be an increase. If it was downhill, it would be an increase-decrease. Yay? This exact same thing, it's just 3 different ways that we're presenting it. This is an L1, this is an L2. Again, we do our stat edit. Then we do our zoom 9. We figure out which one matches the closest. Because this one's going downhill, this one's going to be an increase, oops, put it on the wrong one. This one's going to be an increase-decrease because it's going downhill. Where for this one, it was going uphill, so it was an increase-increase. And this one was an increase-decrease. So y'all only have one of those on the test, but I gave you 3 in the homework just to give you different ways to look at them and practice them. Cool? All right, mean, median, and mode, and mid-range. I did them all in one problem, but if we look on our review, handouts and study sheets, go to the bottom, final exam review spreadsheet, open it. So even though on your homework it's one problem, on the exam these are going to be separate problems. That's why I say your homework review is a whole lot harder than what I think your exam's going to be. And your exam is multiple choice, so you have an eeny, meeny, miny, mo to pick from. So let me get this pulled up and show you. And plus I will be in here, so if you screw something up on your on your calculator or mess something up, I will be in here to talk to you about it. So let me make this a little bit smaller so we can grab that. Okay, so we've done the stem plot, we talked about the dot plot, we've done the scatter diagram. And not only do we have to look at the scatter diagram, we have to say, is there no correlation, positive correlation, negative correlation? We just done that. We hadn't done that one yet, but mean, median, those are 2 separate problems. Okay? Now, even though I put on the homework mid-range and, what did I just say, mean, median, mode, do you see median and mid-range and mode all on there? This is your exam, y'all. I don't see, all I see is find the mean, find the median. I do not see mid-range and I do not see mode. I just see mean and I see median. Nowhere on here does it say calculate the mid-range or calculate the mode. So it was part of the problem that I put out there, but you only need to know how to do the mean and the median. That's it. We good? The mean, you can either add them up and divide by how many numbers you have, and you can put them in order and pick the one in the middle. What if there's 2 numbers in the middle? Add them up and divide by 2. Or you can put them in L1 under stat edit, and then you can go to stat calc and do what? 1 var stats. Your mean is going to be which one? The X bar, and your median is going to be the MED. Okay? So I don't care which way you do it. You may want to do it both ways and double check that you did it correctly. So you really don't need to know the mode and the mid-range because that wasn't on the review sheet. So I did do several of these. Here's the mean, here's the median. I gave you some to look at, so when you're doing your homework, you have something to go by and say, okay, here's the answers, here's how she did it, but we don't need to know mode and mid-range. Here's another mean, here's another median. This one talks about the median. Hold on, I didn't move. Did I have answers on these or not? No, those answers were written out. Here's another one. This just shows you her putting it, them putting it in order with the answer. I can just as easily come over here just to show you the other way and do stat edit, go to the top, clear enter, come over, go to the top, clear enter, This is a short one, 81, 71, 202, 213, 269, 248, 242. Type my data in, and then do stat calc, 1 var stats. We are only looking at L1. I don't want the first page, I want the second page. I hope if I grabbed it. And it shows you right there as well that your median is 202. Cool? Okay, there's, what am I doing here? Find the mean. I would do the same thing as above, except I would look for the mean as my X bar. I'm not going to spend too long on those because most of us know how to do those. Now, this one talks about, and in your spreadsheet, this one is called the, in your spreadsheet, this one is called the weighted mean. This is like what I was doing at the beginning of class, saying everything in this class counts 80%, your exam counts 20%. Well, in this one, your midterm counts 20%, your project counts 10%, your homework counts blah, blah, blah. Now, there's two ways you can do this problem. You can either call this your L1, call this your L2, and do a 1 var stats of L1 comma L2 and find your X bar. That's one way you can do it. Or you can just say, I want to do 20% times the grade plus 10% times the grade plus 30% times the grade plus 40% times the grade. Either way, those are going to give me the same answer. So if I list these in L1 and these in L2 and do 1 var stats, making sure that I do L1 comma L2 or do L1 L2 and look for the X bar, which is the average of both of those. That's one way to do it. Or I can say 20% times the grade plus 10% times the grade. Either way you want to do it, they're going to give you the same answer. Do I need to work that one out? Now, this one's a little bit harder, and the only reason it's harder is because they did not tell you what her test grade was. They told you that they made 4 test grades, but they didn't give you the test average. So what you had to do, they told you that on her exam she made that and it was 30%. She made that and it was 10%. She made that and it was 20%, but they didn't tell you the average of this. So what you had to do is you had to add up all of her grades and divide by 4 to get her test average. So this would be your L1, and in your L2, you would put this, 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 and this. And you would do 1 var stats of L1, L2. L1, L2, and find the X bar. Or you can say 40% and she made a 79.5. Plus 30% and she made a 78, plus 10% and she made an 86, plus 20% times the 87. That's going to give you the same exact thing. You're taking the percentage times the grade plus the percentage times the grade. The only difference is you had to figure out what her test average was before you could work it out. Cool? Alright, this one says find the range, the variance, and the standard deviation. So we need to know, do we need to know all these things? The range, the variance, and the standard deviation. So we have range, we have variance. I do not see where we have to find, it says given the standard deviation, but I do not see where we have to find the standard deviation. I just see calculate the variance, calculate the range. Does anybody remember how to find the range?
Plug them all in.
Range is max minus min, or high minus low. I don't think that one's written on your formula sheet. The range is the high minus the low, so you're going to need to memorize that. So if your weight ranges from 180 to 160, you have a 20-pound range. It's the high minus the low. Now, you also have variance. What is your variance? Standard deviation squared. So even though they didn't ask us to find standard deviation, we have to know the standard deviation to get the variance. So, for this problem, they want to know the range, they want to know the variance, and they want to know the standard deviation, which they really didn't even have to ask because we got to know it to get this. So, my range is going to be max minus min, or high minus low. So my high is 90, my low is 7, so my range is going to be 83. Now, how am I going to get my standard deviation? We're going to type it into L1, so we're going to do stat edit, go to the top, clear enter, and we're going to type it in. Okay, and I'm just going to move this down so we can kind of see what I'm doing. So I did stat edit, I typed it in, and now I'm going to do stat calc 1 var stats. I'm only leaving L1 in there because I only have one list. Okay, there's the first page, and I'm going to move down to show you the second page. Now, technically, since we had to get the standard deviation, I could have gotten my maximum from there and my minimum from there. If I didn't want to look too hard, I could have gotten them from there. Now, what is my standard deviation going to be? Because this is a sample of 11 players, my standard deviation is going to be the 30.2 blah, 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 blah. So my variance is going to be my standard deviation squared. So I'm going to take the 30.20866 and I'm going to square it. And y'all, it's multiple choice, so you don't have to go that many places behind the decimal, because usually I don't have but more than 1 or 2 places behind the decimal for the multiple choice answers. So I'm going to do 30.20866 to the second. So that is going to be my variance. Find a spot to put that. So my variance is going to be that. So they had a couple of things. They wanted to know what is the range. My range is 83. They wanted to know for this one what is my standard deviation. And then finally they wanted to know what is my variance. Cool? And on your homework, I put several of these. So here's another one. Prices for a one night, because we're doing sample, my standard deviation is going to be my SX. So I do my stat edit, put all my stuff in L1, then I do my stat calc, and my SX is going to be my standard deviation. So my variance is going to be my standard deviation squared. So they got this from my SX, and they took that number and squared it, which is where they got this from. And then from our range, they found the high, they found the low, and you can also get it from Stat Calc, one of our stats, and you can get your max and your min, and that's where they got the range from. So you have another one to look at. This is your max minus your min. And they wrote sample because this is sample data. That's telling you to get your SX. Move these down a little bit. All right, this one just says find the variance. We only want to know the variance, so we're going to do standard deviation SX squared. So standard deviation squared. So we're going to do one var stats, find our SX, and then square it. Yay? I have an answer, 7.7. This one just says find the range. So we take our high minus our low, or our max minus our min. All right, now let me cover up for a second so we can talk about this next one. It says your human body temperature has a mean of 98.2 with a standard deviation of 0.62. Sally's temperature can be described by a z-score of -0.5. What is her temperature? Okay, so if we want to draw a picture, we have that. We have a mean of 98.2. We have a standard deviation of 0.62. And we have a z-score, it's negative, which means it's going to be on the left, of -1.5. I want to know what is her actual temperature. So I'm not doing any shading. I'm not doing probability. I'm not doing percentage under the curve, which means I'm not doing a normal CDF or an inverse CDF. I'm talking about z-score. So do we remember the formula for z-score? What does z-score equal?
Is it data minus mean or divided by standard deviation?
I love you. Data minus mean over standard deviation. Data minus mean over standard deviation. So, what am I going to plug in place of z? The -1.5. Okay. What am I going to plug in place of anything else? X is going to be my data because it says what is the temperature. That's my data. That's what I want to know. Minus what is my mean? 98.2. And what is my standard deviation? 0.62. Okay. So the first thing, and there's several problems in here where you have to know, and I'm going to say memorize. You've got to know what the z-score, or z is. Z equals data minus mean over standard deviation. So now we've got to do a little algebra. We've got to figure out how to get x by itself. So what do I need to do to both sides to start getting x by itself?
Multiply by 0.62.
Multiply by 0.62. We've got to get rid of that hussy downstairs. Okay? So I am going to multiply by 0.62, multiply by 0.62. That gets rid of that hussy downstairs. Oops. Undo. That gets rid of that little hussy downstairs. Okay? So on the front side, I have 0.62 times -1.5. Some room over here. Let me copy all of this and pull it over here. Pull it down further. Okay. Okay, so on the front side, I'm left with -0.93 equals x minus 98.2. What do I need to do now?
Add
We need to add the 98.2, because now we've gotten rid of the hussy, we need to get rid of our girlfriend. So I need to add 98.2 to both sides, so I'm gonna do plus 98.2. So my X, or my data point, is going to be 97.27. My data point's gonna be 97.27. And they, Miss Sally helped me work some of these problems out. She just did it by a little less steps. And she didn't draw the picture. This is the mean, this is the standard deviation, that's the z-score, and she didn't write z equals data minus mean over standard deviation and times 0.62 times 0.62, rant. And then she flipped sides on me, so that's why I rewrote it.
And that one's gonna be on the test.
Anything that you're seeing here, I had the test in my hand when I made this. Hint. Here's another one. Find the z-score. Find the z-score. So that is screaming exactly what we did just now. Find the z-score. So the z-score is data minus mean over standard deviation. So we've got to just figure out where to put things. Where does that 28,000 go? That's your mean. So 28,372.72, that is my mean. Where does the 2,000 go? My standard deviation, that goes on the bottom. And on Tuesday, the store sold 34 and some change. That is your data, because the question says find the z-score. So the z is what we don't know. So 34,885.21. So this one, we don't have to get anything by itself because it's already alone. So for this one, we will do 34,885.21 minus 28,372.72 divided by 2,000. Now, look at our answer choices. 3.26. There's only one answer. There's 3.26, which is the first one, but we need to know why the answer is yes. It says, was it a significantly good day? In order to be significant and not significant, how many standard deviations does it need to be? Within how many? 2. So in order to be significant, it has to be within 2 jumps. 2 jumps on either side. So we're, y'all, at 3 jumps. We just did jump, and some change. So it says, was it a significantly good day?
Yes.
It was significantly high. If it's within this range, it's not significant. It's ordinary. It's ordinary if it's here. But if it's there, it's significantly high. If it's this way, it's significantly low. So if it's within 2 jumps, it's normal.
Just an outline.
Correct. So because it is over 2 jumps, it is significant. I'm going to put not normal.
How do we know it was over 2 jumps? 3?
Yeah, because this is your z-score. Your z-score tells you how many jumps it is. So the z-score is the number of jumps. Z equals 3.25. So my data is 3.25 jumps away. Now, here's a very similar one, and I'm gonna show it to you kind of already worked out. It says, draw the picture so you can kind of see. It says we have a bunch of women. The mean is 74. The standard deviation is 22.9. And the lowest pulse rate